Venus is a beautiful, elegant planet, seemingly very calm and almost tranquil on the surface, wrapped in a soft cloud like a blanket. From an outsider's perspective, it's clear why it's named Venus, the Roman god of love. But go beneath the cloud layer, and you'll find quite the opposite. Scorching temperatures, volcanism, and a crushing atmosphere are what you'd actually find on the surface. There are few places in our solar system more deadly, and its acid-laced environment makes visiting next to impossible. So what do we know about this beautiful yet hellish planet? More than you might think. Hi, I'm Alex McColgan, and you're watching our channel Digital Discoveries. Join me today as we delve into what makes this planet so unique in our solar system. Get ready to find out everything you can want to know about Venus. Let's start by stepping back a bit to see where this planet fits into our solar system. Venus is the second planet from the Sun and is often referred to as Earth's sister planet due to its similar size, mass, and density. It is our closest planetary neighbor, located at an average orbital radius of 0.72 astronomical units, AU, or roughly 108 million kilometers. Venus orbits the Sun in almost a perfect circle with the least eccentric orbit among all the planets, meaning its distance from the Sun does not vary significantly. At its closest approach to Earth, Venus comes within 41 million kilometers of us, making it the closest of any planet in the solar system. Despite its proximity, Venus is not always brightest when nearest to Earth. When Venus is closest, we observe its night side as it lies between us and the Sun. Yet, it remains visible due to sunlight refracting through its dense atmosphere. Interestingly, Venus shines most brightly in our night sky when it appears as a thin crescent, its light scattering and reflecting off its thick clouds. This remarkable brightness often causes Venus to be misidentified as a UFO. A famous example includes U.S. President Jimmy Carter's sighting in 1969, later attributed to Venus after further analysis. Its radiance has inspired countless similar reports from amateur stargazers. The visual allure of Venus becomes even more compelling through telescopes, where its crescent shape is distinctly visible. Its position between Earth and the Sun might lead one to ask whether Venus ever eclipses the Sun as seen from Earth. The answer is yes. These events, known as transits of Venus, are rare astronomical phenomena. Transits occur in pairs 8 years apart, but these pairs are separated by over a century. The last transit occurred in 2012, and the next will not happen until 2117. This rarity arises from Venus's orbital plane being slightly tilted relative to Earth's, combined with its 584-day cycle of catching up with Earth in its orbit. Venus's rotation adds another layer of intrigue. Unlike most planets in our solar system, Venus rotates in the opposite direction of its orbit, a phenomenon called retrograde rotation. Even more fascinating, Venus has an exceptionally slow rotation rate, taking 243 Earth days to complete one rotation. This means a single day on Venus lasts longer than its year, which spans 224 Earth days. A solar day on Venus, from one sunrise to the next, is shorter at 117 Earth days. Venus's slow retrograde spin results in a surface rotation speed of just 6.5 kilometers per hour at the equator, slower than a human's walking pace. Its unusual rotation may be due to a massive collision billions of years ago, tidal interactions with the Sun, or the effects of its dense atmosphere. Though Venus's mass and size are strikingly similar to Earth's, this is where the similarities end. Venus's atmosphere is 93 times denser than Earth's, exerting surface pressure equivalent to being 1 kilometer beneath Earth's oceans. Composed primarily of carbon dioxide, with clouds of sulfur dioxide and sulfuric acid, Venus's atmosphere traps heat through an extreme greenhouse effect. The average surface temperature of 462 degrees Celsius surpasses even that of Mercury, despite being farther from the Sun. Venus's thick cloud cover reflects about 90% of sunlight, allowing only a small fraction to reach the surface. These clouds obscure the planet's surface from direct observation, but create lightning and acid rain. The latter evaporates before reaching the ground. Despite its harsh environment, Venus has been extensively studied, revealing a volcanic surface dotted with large lava plains and towering mountains. Soviet probes like Venera captured the first images of Venus's terrain, showing a rocky, desolate landscape with visibility of up to 1 kilometer. Venus lacks a magnetic field, unlike Earth, likely due to the absence of a dynamo effect in its core. This allows solar winds to strip lighter molecules from its atmosphere, forming a comet-like tail that occasionally interacts with Earth when the two planets align. The mysteries of Venus continue to fascinate scientists and enthusiasts alike. Its extremes, ranging from deadly surface conditions to its unexpected Earth-like qualities at higher altitudes, make it one of the most intriguing planets in our solar system. Venus's position in the solar system. Let's start by placing Venus in the context of our solar system. Venus is the second planet from the Sun, orbiting at an average distance of 0.72 astronomical units, AU, or approximately 108 million kilometers, 67 million miles. Its nearly circular orbit is the most stable of all the planets, with an eccentricity of just 0.007, meaning it deviates very little from a perfect circle. This is in stark contrast to Mercury, which has a highly elliptical orbit. As Earth's closest planetary neighbor, Venus approaches within 41 million kilometers, 25.5 million miles, at its nearest. This proximity allows it to outshine every star in the night sky, often earning it mistaken reports of being an unidentified flying object, UFO. Even U.S. President Jimmy Carter once misidentified Venus as a UFO in 1969. Venus's visibility fluctuates based on its position relative to Earth and the Sun. Interestingly, Venus appears brightest not when it is closest to us, but when it is at a crescent phase. This occurs when its sunlight-scattering atmosphere reflects more light toward Earth. The interplay of light and shadow during these phases has been an object of fascination for astronomers for centuries. Unique orbital and rotational features. One of Venus's most peculiar characteristics is its retrograde rotation. It spins in the opposite direction to most planets in the solar system. While Earth, Mars, and most other planets rotate counterclockwise on their axes, Venus rotates clockwise, completing one full rotation in 243 Earth days. This retrograde motion may have been caused by a massive collision early in Venus's history or by gravitational interactions with the Sun or its dense atmosphere. Adding to the intrigue is Venus's slow rotation. A single day on Venus, 243 Earth days, is longer than its year, 224.7 Earth days. However, due to its retrograde motion, a solar day, from one sunrise to the next, lasts 117 Earth days. This means that an observer on Venus would see just under 2 sunrises and sunsets during a Venusian year. Despite its sluggish rotation, Venus's cloud tops are propelled by strong winds moving at speeds of up to 360 kilometers per hour, 224 miles per hour, completing a full rotation around the planet in just 4 to 5 Earth days. This phenomenon, known as superrotation, creates a dynamic upper atmosphere starkly different from the stagnant and suffocating conditions at the surface. Venus's surface and atmosphere. Venus's surface is one of the most hostile environments in the solar system. Its thick atmosphere, composed primarily of carbon dioxide, 96.5%, with traces of nitrogen and sulfur dioxide, exerts a surface pressure 92 times greater than Earth's, equivalent to the pressure found 1 kilometer, 0.6 miles, beneath Earth's oceans. This oppressive atmosphere creates an extreme greenhouse effect, trapping heat and maintaining an average surface temperature of 462 degrees Celsius, 864 degrees Fahrenheit, hot enough to melt lead. Unlike Earth, where temperatures fluctuate with latitude, time of day, and season, Venus's surface temperature remains remarkably uniform, even at the poles and during its long night. This is due to the planet's slow rotation, thick atmosphere, and negligible axial tilt of just 3 degrees, which minimize seasonal variations. The surface of Venus is covered by vast plains of solidified lava, interspersed with mountainous regions and volcanic features. Radar mapping, primarily conducted by NASA's Magellan spacecraft in the 1990s, revealed that approximately 80% of Venus's surface consists of volcanic plains, with the remaining 20% comprising highlands and volcanic peaks. Notably, Venus has more large volcanoes than any other planet in the solar system, with 167 volcanoes exceeding 100 kilometers, 62 miles in diameter. These include shield volcanoes similar to those in Hawaii, as well as unique structures called coronae, circular formations thought to result from upwellings of molten rock. Despite its volcanic terrain, there is no definitive evidence of current volcanic activity, although some studies suggest that Venus may still be geologically active. Historical exploration of Venus. Venus has long been a target of exploration, starting with the Soviet Union's Venera program in the 1960s. Venera 7 became the first spacecraft to successfully land on another planet in 1970, transmitting temperature data from Venus's surface before succumbing to the extreme conditions. Subsequent missions, such as Venera 9 and Venera 13, captured the first images of Venus's rocky landscape, revealing a barren, desolate world. More recently, missions like the European Space Agency's Venus Express and Japan's Akatsuki spacecraft have focused on studying Venus's atmosphere, climate, and cloud dynamics. Future missions, including NASA's Da Vinci Plus and Veritas, aim to uncover more about Venus's geology, atmospheric composition, and potential for past habitability. A unique magnetosphere. Unlike Earth, Venus lacks a global magnetic field, a surprising discovery given its similar size and composition. Scientists theorize that this absence may result from Venus's slow rotation or the lack of a major impact event like the one that formed Earth's moon. In the absence of a magnetic field, solar wind directly interacts with Venus's upper atmosphere, creating an induced magnetosphere and a comet-like tail of stripped atmospheric particles. The mysteries of Venus. Despite decades of study, Venus continues to pose questions that intrigue scientists. For instance, its retrograde rotation, extreme atmospheric conditions, and potential for past habitability remain topics of active research. Some studies have even speculated about the possibility of microbial life in the more temperate upper layers of Venus's atmosphere, though no definitive evidence has been found. As our exploration of Venus continues, this enigmatic planet may hold clues to understanding not only its own evolution, but also the broader dynamics of planetary systems, including the fate of Earth-like worlds. Thank you for exploring Venus with Digital Discoveries.